Okay, so I'm going to start with doing a bending moment diagram for the 3-point bend test. And in order to do that, we need to consider the forces that are acting on this. Left a lot of room there. But we have a force acting downwards here of F, and obviously we have reactive forces in the opposite direction from these two rollers here. So we treat this as a beam that's supported at one end, and we basically start here at point 0 and we move across and we analyse the forces that are applying. And remember that a moment is force times distance. So what force is being applied here is an upward force at point 0, but obviously it's going to be a bending moment of 0 because we're at length 0. As we move this way, the force is going up because we're going that way. The bending moment's going up. Just remembering the convention that clockwise, downwards is negative. And we keep going up until we reach the central point here. And now we have another force coming into play, which is the downward force F. We have an upward force of F over 2 multiplied by the distance. And now, at this point, we've got a downward force of F multiplied by the distance from this point 0. But of course what we're really doing is we're taking one from the other. So up to the midpoint we're going up, and then we go down again. So the bending moment diagram starts off at 0, finishes at 0, and goes to that point there. I won't bother doing the maths, it's just the principle I'm trying to explain there. So that's what the bending moment diagram looks like for a 3-point bend. Okay, we can do the same analysis here for the 4-point bend. Here we've got F over 2 reactive force, and we're applying the force at 2 points here, so that force is also F over 2. So what we end up with here, if that's 0, with the bending moment diagram, we'll just take those 2 points down there, and the zeros there, we end up with this. So we have a point here where the bending moment doesn't change, whereas with the 3-point bend, the bending moment goes up to a maximum at this point where we're applying the load and then goes back down again. And if we analyse the shear forces that are operating, we find something like this. So what's happening here is that, again, we start at this point and we're taking sections through this as we go along, and we're finding that we have an F over 2 upwards. All the way here we have an F over 2 upwards. And then we reach the midpoint, and then we've got an F downwards. So we've gone from F over 2 upwards to minus F over 2 until we get to this point where we have an F over 2 upwards, so that goes back to 0. So that's the shear force diagram. Now this is telling us that at the point of maximum loading, where we have the maximum bending moment, we also have this change in the shear force. If we look at this diagram, if we look at this type of test, the 4-point bending, we've got F over 2 up until we get to that point, then that cancels out, so that stays at 0 until we get to that point, and then it will become minus F over 2 until we get to this point where they cancel out. So it's going to look like this. At the point 0, it goes up to F over 2. When it reaches this point here, that cancels out, so that is now 0. When it gets here, it becomes minus F over 2 until it reaches this point here, and then it goes back to 0. So the shear force diagram looks quite different. We've got no shear forces operating between these points. So these two tests will measure different things.